Okay, so this is the review for your multiple choice test. All right, so let's take a look at number 1. It says to simplify and express with only positive exponents. All right, so notice I have this fraction, this whole fraction raised to this power of 5. So remember, when we have a power to a power, everything inside the parentheses is going to be raised to that power. So we're going to multiply everything by 5, because power to a power, we multiply by 5. Multiply the powers together. So we have x to the negative 2 to the 5th is x to the negative 10th. Y to the 3rd to the 5th is y to the 15th. In the denominator, I have, that's just x, it'll be x to the 5th. And y to the negative 1 to the 5 will be y to the negative 5. Okay, so we're going to have, like I said, x to the negative 10. Y to the 15th over x to the 5th, y to the negative 5. Now, when we divide same bases, the x's and the y's, when we divide same bases, remember we subtract the exponents. All right, so we have, this is going to be x to the, now we have negative 10 minus 5 is negative 15. And 15 minus negative 5 is going to be y to the 20. Now, it does say write with only positive exponents. So I have this negative exponent here, x to the negative 15. So remember, to make the exponent positive, it goes into the denominator. So it'll be y to the 20 over x to the positive 15. All right, so let's take a look at B. Same thing, we have the power to the power here. So remember, we multiply the powers. Okay, so we have x to the 2nd raised to the 3rd power. So that'll be x to the 6th. Y to the negative 6 to the 3rd will be y to the 18, negative 18. And then we have x to the negative 4 to the 3rd would be x to the negative 12, and then y to the 1st to the 3rd be y to the 3rd. All right, so we're going to get here x to the 6th, y to the negative 18, over x to the negative 12, y to the 3rd. And same thing as before, when we divide same bases, the x's, we'll subtract the exponents. So we're going to get x to the 6 minus negative 12 is 18. And negative 18 minus 3 would be y to the negative 21. And again, to make the exponent positive, it's going to go into the bottom. So it'll be x to the 18th, y to the 21 power. Okay, so let's take a look at number 2. All right, so number 2 is to find the quotient. So you could either do long division or you can do synthetic division. So I'm going to do synthetic division. So remember, we're dividing by x plus 2. So I'm going to put this 0 on the outside. So it's negative 2 that goes on the outside. And inside my bar that I'm going to create are all the coefficients. So I'm going to set that up here. I put negative 2 on the outside. And then all the coefficients. So I have 1, positive 5, negative 2, negative 15, and 1. So remember, the first thing we do to start off, we drop the first number, 1. Then I multiply that by negative 2, and I get negative 2. Add straight down. 5 minus 2 is 3. Multiply by negative 2 is negative 6. Add straight down, we get negative 8. Times negative 2 is positive 16. Add straight down. Negative 15 plus 16 is 1. Multiply by negative 2, and I get negative 2. Add straight down, we have a remainder of negative 1. So remember, this is your remainder. Constant x, x squared, x to the 3rd. So your quotient is x to the 3rd plus 3x squared minus 8x plus 1 minus the remainder over what you're dividing by, x plus 2. Okay, so let's take a look at B. So I'm dividing here by x minus 2, so I'm going to put a plus 2 on the outside of my bar. Put all my coefficients, so we have 8, negative 13, 1, negative 10, negative 12. All right, bring the first number down, I get 8. Times 2 is 16, add straight down, negative 13 plus 16 is 3. Times 2 is 6, add straight down, I get 7. Times 2 is 14, negative 10 plus 14 is 4. Times 2 is 8, and then negative 12 plus 8 is negative 4. So this is your remainder, constant x squared, x to the third. So it's going to be 8x to the third plus 3x squared plus 7x plus 4 minus 4, because that's my remainder, over what we're dividing by, which is x minus 2. Okay, so let's take a look at number 3. So 3 says, what is the domain and range of the function? So let's graph these on the calculator. Okay, so number 4 says to determine where the function is increasing and decreasing. So I don't know if you recall, but this is when I draw the number line underneath. So I'm going to draw a horizontal number line underneath. Right, so here's my horizontal number line underneath. And what I'm looking for is the turning point, because the turning point is where the graph changes direction. And since I drew an x-axis underneath because it's horizontal, I really want the x value here. So this x value is 3. So I'm going to put that x value here on my number line. Remember, all the way to the left on the number line is negative infinity. And all the way to the right on the number line is positive infinity. Okay, so let's see what's happening. Your graph is going down. Here, it's negative. It's decreasing. It's going up here. It's increasing. So your graph is, we just have to write this. So it's decreasing from negative infinity to 3. And it's increasing from 3 to infinity. Okay, so let's work with the other graph on the other side. So again, we're going to draw a number line underneath. Remember, it's horizontal, so it's representing the x-axis. Since I'm looking for, since I'm drew an x-axis, I'm looking for my x value at my turning point. So this here is going to be 1, 2, 3, negative 4. So I'm going to put that down here on my number line, negative 4. Negative 4. All right, now your graph here is decreasing here, increasing here. So the ends are negative infinity, positive infinity. So now we have it's decreasing from negative infinity to negative 4, and it's increasing from negative 4 to infinity. Okay, so let's take a look at the next one. So number 5 says to solve for x. So notice these are exponential equations. So I want to get the same base. So I can't write 32 with a base of 8. So you're going to have to change both bases. So another way to write 8 would be with base 2. So 2 to the third is 8. And now I have to raise 8 to that exponent, which is 2x plus 1. And then 32 would be 2 to the fifth, and raise that to the x minus 3 power. So remember, power to a power, you multiply the power. So it's 2 to the 6x plus 3, I distributed, equals 2 to the 5x minus 15. Now that they have the same base, base 2, we set the exponents equal to each other. All right, so I'm going to minus 5x from both sides, I get x. Minus 3 from both sides, I get negative 18. So x is equal to negative 18. All right, so let's take a look at B. So I have a fraction here. So remember, to make the fraction an integer base, I take the denominator and I push it up top and put a negative exponent there, so negative 1. So on the other side, I still have 81 to the 5x, sorry, the color changed, to the 5x minus 2 power. Eight to the 5x minus 2 power. Okay, so let's get them to be the same base. So I'm going to use base 3. So it's 3 to the third is 27. Raise that to the negative 1. And 3 to the fourth is 81. Raise that to the 5x minus 2. So it's 3 to the negative 3, power to a power, multiply the powers, and 3 to the 20x minus 8. Set the exponents equal because now they have the same base of 3. So negative 3 equals 20x minus 8. Add 8 over, we get 5 equals 20. Divide by 20, we get 1/4. Okay, so let's take a look at what's going on the flip side. And then okay, so we have a trig function here. So we have express as a function with a positive acute angle. So when, first of all, you see positive acute angle, you want to think reference angle. Okay? All right, so I have here sine of 335. So let's first draw a picture. So 335, right, that terminates in quadrant 4. So here's 335. So I want the reference angle, I want this angle here. So to get the reference angle, we do 360 minus 335, which is 25. So the reference angle is 25. So does that mean these are equal? Well, almost. So remember, 335 is in quadrant 4, and sine is negative in quadrant 4. 25 is quadrant 1, and sine is positive in quadrant 1. So they're the same but opposite right now. So to make them the same, you have to make the sign negative. So the answer is negative sine 25. Okay, so let's take a look at the next one. We have tangent of negative 260. All right, so let's draw a picture. Negative 260, remember, opens down because it's negative. Negative 260 is going to terminate in quadrant 2. So there's negative 260. So I want the reference angle. So remember, the reference angle is terminal side to x-axis. That's the reference angle. So to get that angle, you're going to do 260 minus 180, right, which is going to be 80. So my reference angle here is 80 degrees. Tangent is negative in quadrant 2, so we have to put negative tan of 80 degrees. All right, so let's take a look at number 7. So 7 is a composition. So I have the composition of g of f of x. Okay, so now remember, g of f of x is really written like this, g of f of x. Right? So we have f of x is equal to 3x minus 2, and g of x is equal to x to the second minus 3x plus 7. So remember, what this means is I'm taking f and I'm plugging it into g, because it's g of 3x minus 2. So I go to g. Wherever I see an x, I'm going to plug in 3x minus 2. So okay, so it's going to be plugging in x here, so it'd be 3x minus 2, square it, minus 3 times your x, which is 3x minus 2, and then plus 7. All right, so I have to double distribute this here. Sorry, I didn't really give myself enough room. Okay, sorry. All right, so I'm going to go over here now so I have more room. Okay, so we have 3x minus 2 times 3x minus 2. All right, so I have here double distribute. We get 9x squared minus 6x plus 4. I'm going to distribute the negative 3, so I get negative 9x plus 6, and then I have the plus 7. All right, so let's combine like terms. We have 9x squared. So I have negative 6 and negative 6x is negative 12x, minus 9x is negative 21x. And then I have 4 plus 7 is 11. All right, let's take a look at B. Okay, so B is, we're doing the same thing, it just have different functions. So it's g of f of x, right? F is 2x plus 1. G is 2x squared minus x plus 6. All right, so we want g of 2x plus 1. So I'm going to take 2x plus 1, plug it into all my x's here. So it's going to be 2 times 2x plus 1 squared minus your x. So just be careful, you do need parentheses because we are minusing, and then plus 6. All right, so let's start with the 2x plus 1 squared. So it's 2x plus 1 times 2x plus 1. So that's 4x squared plus 2x plus 2x plus 1. So that's 4x squared plus 4x plus 1. And then I have multiplied by 2. Okay, so multiply by 2, I get 8x squared plus 8x plus 2. Distribute the negative. We get negative 2x minus 1. And then I have the minus 6. Plus 6, sorry. Combine like terms, we get 8x squared. 8x minus 2x is 6x. 2 minus 1 is 1, plus 6 is 7. Okay, so let's take a look at number 8. Okay, so number 8, we're expanding the expression. So we have log base A of the square root of 18 over 31. So remember, the first thing you can do is you want to change this to exponential form. So a square root, remember, is a 1/2 power. So it's going to be log base A of 18 to the 1/2 power over 31 to the 1/2 power. Now remember, we have division, so division means to subtract. Each one gets a log, so it's log base A of 18 to the 1/2 power minus log base A of 31 to the 1/2 power. And then remember, exponents go in front. So it's 1/2 log A of 18 minus 1/2 log A of 31. Now remember, because they do both terms have a coefficient of 1/2, it can be written as 1/2 log base A of 18 minus log base A of 3. Okay, so let's take a look at B. Okay, so B is log base X, the cube root of 8 over 11. So remember, a cube root to start off with is a 1/3 power. So we have log base X of 8 to the 1/3 power over 11 to the 1/3 power. All right, so we have log base X of 8 to the 1/3 power minus, because it's division, log base X of 11 to the 1/3 power. Exponents go in front, 1/3 log base X of 8 minus 1/3 log base X of 11. And remember, this can be written, if we factor out the GCF of 1/3, 1/3 log base X of 8 minus log base X of 11. All right, so let's take a look at number 9. Oh, okay, so this is inverse. Right, remember, this is the inverse symbol. Inverse means to switch X and Y. All right, so I'm going to go down here on the bottom. All right, so I'm going down here. So I switch X and Y. So remember, this is Y equals 2 the square root of X plus 7. So I'm switching X and Y. All right, so we want to solve for Y. So I'm going to minus 7 over X minus 7 equals 2 the square root of Y. Now, you can't square both sides yet because of this 2 in front, so divide by 2. So then we get X minus 7 over 2 equals the square root of Y. Now you can square both sides. And you can leave the left side as that fraction squared. So equals Y, and then you use the inverse notation. So it's the inverse of f of X equals X minus 7 over 2, the whole thing squared. All right, so let's take a look at B. So B is Y equals, we have 3 times X minus 4 squared equal plus 5. Okay, so the first thing I'm going to start doing is switch X and Y. So we have 3 parentheses Y minus 4 squared plus 5. So minus the 5 over. Okay, you can't square root to get rid of the square yet. You got to isolate. So divide by 3. So we have X minus 5 over 3 equals Y minus 4 squared. Now you can square root both sides. So I get the square root of X minus 5 over 3 equals Y minus 4. Now add the 4 over. Sorry, it's the whole thing, sorry. Square root of the whole thing. And then add 4 on the outside equals Y. Don't put that 4 underneath because that came after we square rooted. So now I'll write it with the right notation. So it's the inverse of f of X equals the square root of X minus 5 over 3, and then plus 4 on the outside. Or you could put 4 plus in the front. Okay, so let's take a look at the last problems. Okay, so the last thing is to factor completely. All right, so remember, always look for a GCF first. I don't see a GCF. So I do notice I have perfect cubes, so I'm going to use SOAP. Remember, same sign, opposite sign, always positive. So let's write down the formula. So we have same sign, so in this case will be minus, opposite sign will be plus, always positive. And remember, it's a squared, b squared at the ends, and in the middle is a times b. A is going to come from the cube root of 125x to the third, which will be 5x. And b will be the cube root of 1, which is 1. So now you just have to plug it in. So 5x minus 1. I don't know why I put equals there, so let's get rid of that. So then we have times. So just be careful here because it's going to be 5x squared plus 5x, because that's 5x times 1, plus 1 squared. So it's going to be 5x minus 1 times 25x squared plus 5x plus 1. All right, and let's take a look at b. All right, so parentheses, same sign, opposite sign, always positive. It's ab here, a squared, b squared. In the middle is ab. All right, so a is the cube root of 64x cubed, which is 4x. B is the cube root of 27, which is 3. So it's 4x plus 3 times, so just be careful here, 4x squared. So now it's a times b, so it's going to be 12x plus 3 squared. So it's 4x plus 3 times 16x squared minus 12x plus 9. Okay, so that's it. Happy studying. See you guys tomorrow.